meal. All right, like Berkeley mentioned, we're going to kick things off here today with a presentation from David Hayes, the CEO and founder at AVO, where he'll be talking about something very interesting on its own, but also very relevant today to this afternoon's pitch competition, which is building an outlier by bringing advanced tech to market. Everyone, welcome David.
Amazing. Max and Berkeley, thank you very much for the intro. Loved the video, just to kick off the day. And I just want to say thank you, everybody, for having me. I'm really excited to speak with you. And if you want to connect with me afterwards, feel free to look me up on LinkedIn. Now, today I want to kind of dive into bringing advanced tech to market, because prototyping and engaging in some cool ideas is one thing, but bringing it to market and commercializing is totally different. Now, just for the record, I'm a car guy through and through, hence why I started the AVO. And I've always wanted to bring advanced technology to the car market. So just bear with me through this presentation because I am a car guy and a gearhead. So I'm just share my screen. Perfect. I believe you can see it now, and we'll kick it off. Okay, so as Max and Berkeley said, name's David Hayes, launched AVO in 2017 with the mission of connecting and protecting people from autonomous vehicles. But what you need to do that is you have to build a stack of advanced technology, and then you have to be able to take it from that minimum viable product and prototype stage, and then actually bring it to market to make a company viable. So what I want to use is some analogies from, or some examples from the automotive industry, and then we'll go into what I did at my company. But mainly I want to talk about outliers. How do you make advanced technology, break the mold of a company? So a company that I think is very well known is the brand Ferrari. When I think of Ferrari, I think of, drop dead gorgeous designs. I think of, extreme performance on and off track. I think of screaming V12s ripping down the streets and canyons, between tall buildings. I think of their racing pedigree. I am a gearhead. I love watching motorsport. And I also think of that beautiful red color. So everything I think about Ferrari when I think about that is embodied in the 1964 250 GTO. I mean, if this isn't a beautiful car, I don't know what is. And when I think of Ferrari, I think of this car specifically. If you look at it at the time, this was the latest and greatest car that was ever produced. The fastest, the loudest, the quickest around a racetrack. Now it looks dated and elegant and beautiful, but at the time, it took a lot of advanced technology to bring this to market. Now, usually what happens is a concept will be drawn up, and then a car will then be put into a prototype stage where you kind of put some things on wheels and give it a motor, and you make it race around and see if it works. But this is the end product. And as a consumer and as people who desire cars, this is what we see and love and eat, sleep, breathe. So then what happened here? This car is recently being built. It is hideous. It doesn't look like it works. It's blocky. This is a Ferrari, believe it or not. And what's really interesting about this car is this is one of those, what we call a test mule. And what a test mule's purpose is to take a concept, allow the engineers to prove the engineering works before you start to productionize that technology. So what you see here is the absolute bare bones of what a Ferrari is in the technological field. I personally think it looks like a lot like a catfish, but that's just me. But what I want to do is I want to take a tangent away from automotive for a second and talk about something really special to me. I want to talk about Krebs' cycle of creativity. I'm not sure if any of you are aware of this, but if you're not, definitely go look this up after the presentation. It's really fascinating. And what it is, it's a condensed version of what I believe is any product or service. It blends art, science, engineering, and design. And the concept here is if you start in the top left quadrant, you'll see that it's all about perception. So this would be your concept drawings, your conceptualization of a problem. And then if you can see inside the circle, the top hemisphere is all about philosophy, right? So how beautiful should a product be prior to taking it to market? Then as you start to migrate to the top right quadrant, you can see that science is starting to be applied to that art. So you have your drawings or your renderings or what your design or your thought, whatever it might be. Now you're going to start to apply science to it in that way of, what are current constraints? What can you do and can't you do with current technology? Then you go to the bottom right quadrant, which, I love. I'm a mechanical engineer by education. I've worked in technology companies ever since launching my company. And so this is the part where you start to see what the current limitations of science are, and then you actually start to see how engineering can impact the innovative nature of that science. And then when you have something special, by the time you've reached the bottom left quadrant, you have a design that you're ready to bring to market. So let's go back to seeing how Krebs cycle is in action with cars, specifically more Ferrari. So let's talk about the art. The concept drawings are always beautiful, elegant, futuristic, and they're usually done by a fantastic graphic artist. They're also idealistic. The designs are not what's going to be put on a road. That's just not the way things work. When you think about something, no matter what it can be, technology, art, music, history, whatever, it's always going to be idealistic in the first conceptualization, and it's limitless. When you think of solving a problem, let's talk autonomous vehicles for a second. Everybody thinks of robotic vehicles going around in harmony, connecting to everybody, and everybody's safe and happy, and there are these little shuttles going all over the place. That's the concept of autonomous vehicles, but then you have to start to apply the science. So you're going to have to build prototypes. They're typically very ugly. They're very functional, but they have massive constraints given the current technology architecture that exists today. So any technology company, whether it's AVO or any other company, you need to understand what those constraints are today and how to break them. Now, from there, what I really want to stress is successful companies take this stage and they prototype very quickly. They don't dwell on a large prototype. They do it incrementally, step by step by step, and they really want to achieve fast results to prove that the concept is doable through science and math and engineering. Now we get to engineering. This is the car you saw just a little while ago, that ugly car. This is the idea of beta testing. You want to put all of your concepts, your innovation onto the road, and you want to hammer it. You want to test it for miles. You want to see what it can do. You want to understand the aerodynamics around a car. More so than that, you actually want to see how your new latest and greatest innovations work in the real world. So the important part here is beta testing. You want a proof of concept, and then you want your minimum viable product, which is something that you could take to a customer and sell in concept. So you can say, okay, Mrs. Customer, here's what we've built. Here's some data to show you what we've built. And this car is going to be the most beautiful and the fastest car in the world. Let's just not show them that picture. But then you look at how to innovate on top of that. So the reason that the car I'm showing you is so innovative is because it's the first time Ferrari ever put a hybrid system in a car. People think hybrid, they think Toyota Prius. But what Ferrari was able to do is they were able to build a better engine that was faster, more efficient, more engaging for a customer through hybrid technology. So that's the innovative portion of that car. But they constantly iterated. They would build a prototype, see how it performed, iterate, and continue. So you see this loop is always going from the iterative process of what have we built so far, and then go back to the current limitations and constraints and continue to engineer around those problems until you achieve your goals, until you finally hit your production. So at this point, you're going to be able to actually mass produce this technology and bring it to market. So that gap is massive. And I definitely want to stress that most tech startups usually eat, sleep, breathe the science engineering portion of this. Very few companies actually end up productionizing a product, which is really what I want to dive into a little bit later. So a little bit abstract still, but let's take it back to the Ferrari example. So how does Ferrari do it? Well, let's take Krebs cycle of design first, or creativity. So from here, we know that in the top left, we need art. So we usually hire concept artists to render some beautiful, elegant drawings that show desire and passion and the brand that has always been Ferrari. That iconic red is identified there. Then we have to start to take it to science. This is where you get your test mules. So you take the concept and you build prototypes. The first prototype will be ugly, but it will be quick and easy to build, relatively speaking. From there, you get better and better through your beta testing. So the second image might not look that different, but it's actually quite close to the final design. Then you start to look at the engineering. So now that you've started to prototype the actual technology, let's start beta testing it. Let's put it in the hands of some racing drivers. So here's one of the early stage prototypes going around one of the most iconic racing circuits in the world. It's still not done. And that's why they use this camouflage paint all over the car, is so that they don't show spy photographers what's really happening under the skin of this car. But it's starting to represent what you need it to represent. And the gap between the top right and the bottom left photos is massive. It's years in development, but the bottom right photo is getting very close production. And then when you're finally done that process and you've tested something thoroughly and rigorously, you end up with this. One of the most beautiful and fast and passionate cars ever built in the world. And if cars aren't your thing, I'm sure you can apply this process to something that you're passionate about, whether it's guitars, whether it's fashion. It's always the same process. When you finally end up with that end product, what it's really taken is a mountain of innovation to build through that prototyping stage. And then finally putting it into production is just a whole other leap and bounds. So in brief summary, what Ferrari built is they built the LaFerrari. Terrible name, I know, but that's what they decided to call this car. It was originally codenamed the F-150, which is also a pickup truck, which is another story. But they set extremely hard goals with this car, which is really important. Whether you're a tech company or whether you're a student, I really stress the importance of setting extremely hard goals for yourself and for your project at hand. They then wanted to innovate. They wanted to bring new technology that has never been done before. So what they did is they took a hybrid engine from the F1 cars. And if you don't know F1, it's Formula One. It's the world's top racing league, essentially, or program. F1 technology only needs to last 150 miles, or 190 miles, sorry. But we know that road cars, they need to be designed to last 100,000 miles. I doubt this car will ever be driven for 100,000 miles. But the importance here is taking the technology out of a race car, which is essentially a functional prototype at best, and productionizing it is a massive endeavor. And it takes Ferrari roughly 4 or 5 years to figure that out. And it rarely gets done. A lot of those projects get scrapped. But that's why this car specifically is so special, because it didn't get scrapped. It made it to the road. That's what I really want to stress here. Putting that engine into this car was a monumental feat, because what it did is it used electricity, which is conventionally known as making cars more boring, less exciting, quieter. But it actually was able to enhance the speed and the excitement of this car. But the engineers, the designers, the leaders of these projects, they had to work extremely hard at understanding how to bring that technology that's only intended to last 190 miles to 100,000 miles. And I'll talk more about that when I talk about my own company. But I just want to stress here, the parallels are massive between this process and what we had to go through as a tech company to bring something innovative to market. So that brings us to tech. To tech. So let's start with design. We know that we want to start with, any tech company needs to start with customer problems. That's critical. Whatever you bring a solution to, it needs to solve a problem. The solution ideally should be elegant by nature, right? So if you look at the drawings that they ended up building for this car, they were elegant, sleek, beautiful. The idea should be the same for a product. It should be elegant. So if you think about an Apple product, the first thing you think about is the look, the feel, the branding, the touch. That's the elegant portion of the solution. Then you need to differentiate your IP, right? So what makes the LaFerrari so special? It was the first time they put 1,000 horsepower into a car. I mean, that's insane. And there needs to be a massive market demand. This gets into the productionizing later on. Then we look at prototypes. So we have our idea, we have our concept, but let's actually see if this thing works. Can we solve the customer problem? Not in the entirety, but piece by piece. So Ferrari's first job there was to take an old body and then put one of those race engines into it to see if it worked, which was that ugly car. So incremental goals. Step 1, put that engine into the car. Will it drive around a track and not self-implode? Build fast and break things. Don't try to build a production-ready prototype. Build little steps, constantly iterate, constantly improve, and always get a little bit better with each step that you take. Iterate, iterate, iterate. I cannot stress that enough. You're going to find problems the more you try. So the faster you build, the faster you fail, the better your product's going to be in the end. And you need to prove that your solution solves that customer problem. Again, it's always coming back to that customer problem. And the better and more advanced a company becomes, you'll actually notice that their customer problem definition is very refined. If you talk to an early stage startup, they might have a one-line answer of what they're trying to solve, but typically if you ask a couple more harder questions, it will branch out. Whereas companies that have been producing technology for a long time, they're very good at describing what they're trying to achieve. Then we need to innovate. So let's start to layer in complexity to these prototypes, right? So not only did you have to put that engine into this car, now we need to make sure that this engine feels good for the driver to use. We don't want it to feel numb, as most hybrid cars do. So now you require, miles of wiring harnesses, software, computers, heads-up displays, graphics that have never been put in a Ferrari before. You're probably going to leverage some sort of machine learning or artificial intelligence to achieve that goal. And then you're going to use your data to validate the fact that you are solving those problems, right? So in the cars example, you could prove that this car is going around a racetrack faster than previous. And beta test. Get this car or your technology in the hands of people who are going to use it. So in a Ferrari's example, they put this car in the hands of racing car drivers. And they ask them, just thrash this car, break it, prove to us where you can break this thing. The same in any tech company. You want to put your tech in a customer's hands so they can manipulate it, break it, troubleshoot. And those beta testers are going to be vital to the success. And then we get into the productionize. Make sure your technology is robust. Make sure it doesn't break, because there's nothing more frustrating than when technology breaks. Make sure you identify how you're going to sell your tech. Is it going to be business to business, business to consumer, or direct? Then you want to make sure you can maintain your technology. That's a whole other element that we haven't even spoken about. We're just speaking about building tech, not maintaining tech. And then you want to make sure that you have some sort of feedback from your user data. So when you actually sell this technology, how do you know people are actually enjoying it? So you could run some marketing initiatives to get some feedback from customers. You could layer in some tech that sends back reports and user reports to your data. It just depends how you want to do that. But the important is you have that full closed loop cycle. So let's just quickly pivot over to what we're trying to achieve, because you'll see a lot of parallels. So I launched AVO in 2017 with the mission of connecting and protecting people to eliminate collisions between humans and vehicles. Obviously, there's not a lot of autonomous vehicles on the roadway, so we knew that the private domain would be adopted first for autonomous vehicles. That means mining, warehouses, construction sites. That's where autonomous vehicles will be adopted first at mass. Oh, sorry. What we're trying to do as a company is we're trying to build the world's first fully connected and autonomous construction site. How do we get there, though? Seems like an audacious goal. Well, first, we need to build real-time site data, and we're doing that today. So through technology that I'll go through in the next couple slides, we're actually representing the site in real time up to 5 hertz, and we're representing where people and vehicles are at all times. And the whole idea is, with this base of the pyramid with real-time data, you can then start to layer in additional technologies. The important piece here is that you want to make sure that this data already solves a customer problem in order to secure funding as well as sales to then continue up the run. So our technology, it understands what's happening in real time on a job site. So when are materials delivered? Where are people walking? How often? How often are they taking elevators versus staircases, etc.? That's the historic data. We can look at data from today, yesterday, last week, last year. Then we're actually predicting what could happen in the future if you start to move things. So let's say, for example, a crane is picking up materials from this spot. Well, what happens if it picks it up from this spot instead? What's going to happen to the flow-through rate of materials? How does that impact the customer's efficiency and site safety? Now we can actually make predictions with our technology, as well as updating that information from the data we're collecting on the bottom rung of the pyramid. So now what we have is we understand where everybody is in real time. We can make predictions of where things ideally should go in the future. Now we're able to connect vehicles. And we know this because we've built a connected and autonomous vehicle as a test mule in our company in 2018, 2019. And that means that we've built this technology with intention and the ability to adopt autonomous vehicles the moment that we start to partner and work with third parties like Caterpillar and CAT. So the technology we've built is called Stratos. And right now it's revolutionizing the construction industry and the prop tech industry, because what we're doing is we're giving data to the customers that they've never been able to have before, situational awareness they've never been able to have before, as well as remote access of managing the site. Previously, if you wanted to manage your site, you'd have to walk on site and understand what's happening personally. In the era of COVID, that's unfortunate because it's very difficult. Stratos gives that ability to manage the site remotely because of our dashboards, our data, all of that real-time analytics we're providing. That's great though. Sounds idealistic, sounds great, sounds like that concept. So how have we actually executed on this? In 2019, we identified that our technology we built for autonomous vehicles, which was connecting people and vehicles in a novel way, would actually transfer really well to the construction industry. And we did that through customer engagements. We didn't go blind. We didn't try to make this up on our own. We actually engaged with enterprise-sized customers who work in the construction and engineering industry. And they identified that not only are construction sites dangerous and inefficient, but autonomous vehicles make a lot of sense. And the underlying data of autonomous vehicles will actually provide them massive insights into how they operate their sites today. So we got that word and we knew we had to pivot. We knew we had to adopt our technology from a vehicle and put it on a job site. So, sounds kind of abstract. I mean, how does a company with only 5 employees, limited budget, do that? Well, this is my main message of the day. I really need to stress the fact that we had innovative tech in a prototype car, but now our challenge was going to be, can we build a functioning prototype to sell the technology to a customer and then actually develop a productionized version of that? So what we did in the first place, we took a cell phone and we hardwired it to a computer. And what we did, we took our computer vision stack that we were using in our vehicle to detect pedestrians, and we actually just put it on a tripod outside of our offices in Toronto, and we just determined, could we recreate this street environment in front of us as a construction site in 3-dimensional space with our technology? We were already doing it in the vehicle, but we wanted to see the capability of doing it in real time, just observing the world as people walked around. So we put a phone with a cell phone camera on a tripod, wired it up to computer, ran our stack locally on a computer, on a laptop, and we had our aha moment of, wow, we can now bring all of this data. We know where people are walking, how fast, their trajectories, where they are in the real world because of our secret sauce IP, which is, again, that differentiated IP I spoke about earlier. And now we can create charts, data, insights, value for the customer. And this is really where our company started accelerating. We absolutely started hitting this point of exponential growth with our success with customers, with investors, you name it. And then in 2020, obviously the pandemic hit. But just before the pandemic hit, we had one of our major meetings with an enterprise customer. And they said, yes, from what you have proven with your prototype and your data, we see a lot of value in this. They didn't sign a contract with us, but they said, if you can prove that you can bring it to a site, we're probably going to need this technology, and it will give us that differentiation from our competitors we need. Because construction has a notoriously slim profit margin. It's only about 5%. And that's really important to note, because if we can give a couple points or a couple percentage points difference between a competitor's bid and their bid, our customers, that's a huge, huge profit for that company. So in 2020, we started brushing our heads around and we said, okay, well, how do we put this on a job site? What do we actually need to do to productionize our computer vision stack to make sure we can render a job site in real time in 3D? Well, again, I said our budget is limited. So what we did is we took off-the-shelf components. We didn't want to develop our own components. That seems like a huge waste of money. So what we did is we took something that was easily adoptable by the construction industry, which was security cameras. We realized that if we could put security cameras and the video feed from the security cameras, send those to the cloud, we could run our computer stack in the cloud at incredible rates and recreate a job site in 3 dimensions 5 times a second. And because of our work from autonomous vehicles, we know that that's going to be enough to plug in connected autonomous vehicles. So where our technology became really creative was the fact that we were able to optimize and improve all of our sensing capabilities to represent the world in 3D in the cloud 5 times a second. And that also means we can then send data back to the job site, whether they are managing the site via tablet or whether we start to put connected vehicles on site, things like elevators, diggers, backhoes, cranes. We can start to give heads-up displays to the operators to either improve safety or improve efficiency, which all has a positive impact on the bottom line of the company. So again, sounds pretty great. Luckily, we were able to do that, and customers started to buy in. They loved that. But let's go a little bit deeper. So how did we commercialize our advanced tech? We'll just briefly touch on this. We know a couple things. Construction sites have people and vehicles. Great. We can measure that. We know that. We know we have AV data that can provide a wealth of information to customers that they don't currently have. And we know that AV tech solves a lot of the problems that the customers have identified. So we took our prototype, which is our little camera laptop setup, and we took the path of least resistance. We just wanted to prove it was possible. The setup was ugly. If somebody were to look at us, they wouldn't see anything interesting or novel. We knew that the solution was innovative because after speaking to customers, we knew that they didn't have any of this data today, especially not at our cadence or our frequency. And we knew our IP is novel in the way that we're able to do this. And lastly, we started to determine that things were quite functional because we were solving those problems that we needed to solve. And then we went back to speak with customers to better understand that the road we were taking with this pivot was successful. So then we got into our minimum viable product we are going to take to the customer. So in one of our customer meetings, they said, can you please just tell us what are you going to bring to our job sites? What's in the box? So that's where we tested, iterate, tested, iterate, tested, iterate. And we were able to be our own beta testers. We actually set up a test lab in Toronto using security cameras we bought off the shelf from the same companies that construction site companies use. That CCTV security setups, we bought the same tech. The reason is when you buy technology that is comfortable for an industry, it's more likely to be adopted than if you bring a stack of complex sensors and LiDAR pucks and radar this and whatever. We just wanted to use technology that was already comfortably deployed on a job site. Then we developed our tech from input from our customer meetings. We used that as our North Compass. And we knew that our simulations had to prove the feature sets were valuable. And then we took data-driven results to iterate. And then we were able to take that data and go secure sales. Well, that's great. That was 2020. Then our little friend COVID hit. And as everybody knows in this room, or at least where you're sitting at home, life threw us lemons and we had to make lemonade. So imagine you're a tech company, your momentum, the wind's at your back, you're skyrocketing, you've proved market fit, you've got this tech that's ready to go. And then your customers at the beginning of COVID stop answering phone calls because every company in the world puts their blinders on and they have to focus internally. They have to think, how are we going to solve this problem of COVID and how are we going to survive? So I took my team and I said, hey, look, the whole world has just shut down. This was March, April of 2020. Let's start to dig into how to productionize this technology. This is a unique opportunity. We're never going to have this opportunity where the world, quote unquote, stops ever again. So let's put our blinders on and let's take the proof of concept, that prototype that we have that we know solves a customer problem, and let's productionize that. So what did we do? We started to do things like make sure it was adoptable. So again, that was where that security camera concept came from. The second was deployable. What do we need to bring this to a site? How easy is it to actually install this technology? How robust is this? Does it scale across multiple job sites? Because if a customer finds value in it the first time, they're going to want it again. That's key. They're absolutely going to want this thing, Stratos, on 5 sites the moment it works on 1. So how quickly, as a small team, can we go and install it on 5 sites? And then lastly, is it stable? Is it maintainable? So if it goes down, how quickly can you fix it? When our prototype was running, we had a bug or a glitch probably once a week, once every 2 weeks when it was running. But through the COVID downturn, what we did is we actually built that simulation lab and we pushed all of our tech to that as if it were a construction site. So we've been running a test site now for about 12 months. And it gives us the confidence to know that we have a very high level of operation with our technology. And the most challenging part is now that you've built a technology that's adoptable, deployable, scalable, stable, maintainable, is it profitable? You can build your models of your business model of profitability in early, but until you actually build your technology with that intent, it's very difficult. And our guys and our team worked really hard at reducing the operational cost in the cloud compute cluster to make our technology absolutely profitable, because we also knew that the landscape of, you know, the conventional cash burn scenario for a tech company, that was going to evaporate. So we actually pivoted to a profitable business model. We know that when we had a certain number of job sites, we're actually going to be a profitable company. We might not need to rely on investment rounds going forward, which is a really strong position to be in as a tech company, especially in this day and age. So let's just kind of come back. Let's come back to Krebs cycle. So in our company, our design, we knew construction sites were inefficient, dangerous, with absolute barbaric minimal site data, and a huge opportunity. So construction is one of the largest industries in the world. And we had preliminary data showing that we were going to make a huge impact on this industry. That all of a sudden makes our technology company exponentially more valuable. So now we've got our right design. Now it's about execution. In the prototype phase, like I said, we set very incremental goals. This week, we're trying to achieve A, B, C. And we know that if we achieve that little small step, let's say we connect the computer in a certain way that, you know, you're able to detect humans and vehicles 2 times more per second. That means we're going to be able to achieve downstream effects as well. So detecting people, detecting vehicles in real time, or at least near real time, was hugely valuable for us in the prototyping phase. Then we were able to create the live 3D map, and that's what we were able to sell to those customers. So at this point, we had already secured product market fit and customer demand simply through, you know, prototypes that were dressed up a little bit. Same thing every industry does. You have to, you know, make sure your prototypes look the part. Then we got into the innovative part through COVID. We actually migrated all of our tech to the cloud, which is a huge endeavor, but that's critical because that means your technology is going to be more stable and more reliable and more secure, which is a huge issue. Then we're able to improve our AI. Now, what I mean by that is we're able to actually take our computer vision stack, which was running at, you know, roughly once every 2 seconds, maybe once every second, and we're actually able to cut it down to 5 times a second. And that opens up a whole suite of features now in our technology that we can start to plug and play with in terms of connectivity. Reduce costs. As a business, to productionize any technology, you need to make sure that your costs are less than your revenue. For sure, to stay alive, we need to do that going forward. So that was a big effort. When we first migrated our technology to the cloud, we had high costs because the technology was a prototype. It was inefficient, the same way that car looked like it would create a lot of drag. From there, we validated our customer with our data with our customers. So we took that data back to the customers who are interested in this technology, and we absolutely validated this is worthy of a large sticker price. That's where it takes us to productionizing it. We needed to exceed customer demand. So currently, the data that's on job sites, to give you an example, they would receive 1 picture a day of site progress. That was kind of what they would get. And then they would get a time-lapse video at the end of a project to see how the time-lapse happened of building a bridge. Yeah, that's not so great. So our technology went from 1 picture a day to 5 pictures or 5 images a second. And that's happening 24/7. And now we can give remote access to that video feed of multiple sites across the country for a site manager for a company. That's a huge advancement for a productionized product. From there, we look at the robust architecture. We know that our technology, I mean, for a scrappy young startup, we can't afford for it to fail. And if it fails, we need to fail safely and gracefully. We can't have a hard crash. So we built in redundancies to make sure that if something goes wrong on a job site, we can then back it up with that video feed and make sure we can reprocess all that data and get it to the customer before they ever have an issue that anything has happened on a job site. And the profitability means we get to stay in business and we get to create that pyramid that we've been talking about connecting vehicles to a job site and making sure that autonomous vehicles can be brought to a construction site. And lastly, scalable. We're just at the tip of the iceberg here. We really need to make sure this technology, the moment we prove at the end of this year of 2021 that customers are going to want it through our pilot projects, they're going to come back and ask for 5 sites, 10 sites, 20 sites globally. Imagine that transition for a tech company. Yeah, it's easy to go drive to one job site, put some cameras on site, and launch some innovative tech. Now do that across the world at 10 sites all at once or 100 sites. That becomes a totally different animal, which is a really exciting endeavor for our company on the near horizon. So in summary, what I want to stress here is, if you love innovating technology, and you just want to research and that's what you love, academia is a great place to start. So being in university, use that time to stay in the top hemisphere of this circle. Design and prototype, have fun, create, iterate, enjoy it. And then as you start to look at graduation or internships, start to look at the right half of this circle, the prototype innovate stage. That's where you'll live. That's where you're going to eat, sleep, breathe. You're going to set some goals, or your manager's going to set some goals. Or you might launch a company and you're going to set your own goals. And then you're going to want to design, iterate, improve, and make sure that you can create that innovative solution to then bring that to the bottom hemisphere where you start to productionize that tech. So I just want to thank you, everybody, for your time. I really enjoyed the opportunity. Thank you, CUCAI, for the great conference. I've enjoyed it. I know my team has as well. And again, I'm happy to answer any questions. If you would like to learn more about what we're doing, feel free to reach out to me on LinkedIn. My name's David Hayes. The really important thing here is I didn't want to make this a sales pitch about our nitty-gritty technology. So if you're more curious about autonomous vehicles, happy to answer questions now or have independent questions later. So thank you very much and happy to answer some questions.
Yeah, awesome presentation, David. Thanks a ton for that. Super relevant to the pitch competition this afternoon. So hopefully we'll be seeing some of the topics discussed there coming back. Sure. Okay, the first thing I want to mention before we jump into the Q&A is, can we distribute your slide decks after? I think we have a couple people asking about it on the event.
Yeah, I'm sure we can. Absolutely.
Okay, awesome. That's great. Okay, let's jump into some Q&A now. We've got a couple questions here that I want to throw up. So let's start off with this one here. So lean startup is a very popular method. Where do you think it gets it right, and where have you deviated from it?
Yeah, I think the great idea of lean startup is, move fast, break things, right? And make sure that you can prove your technology solves a problem quickly and use the minimum amount of resources you need. And that's what we did. Think about it this way. A normal budget to create an autonomous vehicle is, hundreds of millions of dollars. We built one with a Honda Civic, some open source hardware, some software that we created, and some off-the-shelf software as well. And we were able to create this autonomous vehicle that can drive no hands, no feet on highway conditions. Is it the best autonomous vehicle in the world? No, but it didn't have to be, because all we needed it to do was prove that it would connect and protect the humans and not hit them. And that was our goal. So we didn't have to make this massive technology endeavor into beating Mercedes, Tesla, Uber, you name it, in their AV stacks. And that's the idea of lean startup. How quickly can you prove your concept with the minimal amount of resources, which is time, money, and basically engineers or people working on the project. And then where we've started to deviate away from that is, now that we're going into productionizing that technology, we're still in the lean startup mode. But now, as we're generating more revenue, more investment, we're going to be able to hire more. And so, for example, the marketing is a great example of where you deviate away from lean startup. You can put an initial pitch deck together, an initial marketing package. Our company does not do this well enough, in my opinion. That's on me. However, I know we'll be hiring marketing initiatives and campaigns and kicking those off later. And that's where you start to put more money into the sales funnel to generate more revenue. And that's where you deviate away from the lean startup method.
Okay, awesome. Terrific answer. Okay, next question here. This is actually a really good one. I was kind of waiting for job displacement to come up in one of the Q&As. So here we go. How will the large job displacement caused by the automation of construction be dealt with?
Yeah, this is a great question. Nobody wants to cause people to lose their jobs. Let's be honest. That's not a very fun place to be. And at the same time, automation is coming, and it has come. I mean, look at warehouses. If you go into the Ford assembly plant in Oakville, I've walked the floor there. It's dark. There's about 15 people in the assembly plant, and it's really weird because these cars are moving all over the place. So automation is already happening, and jobs are already getting displaced. But let's just specifically zone in on construction. Everybody thinks of autonomous vehicles and autonomous construction sites as binary. You either don't have any or everybody's out of a job and the site gets built by itself with a whole bunch of 3D printed materials and some cranes that get operated by vehicles and all that stuff. That's not what's going to happen. It's going to be a gray scale. You're going to have a gradual process going from 0 to 100. And what I mean by that is, in the next 5 years, we'll get to a connectivity level where you have operators getting heads-up display feedbacks in their truck cabins. So they're still going to be working. When we go down, let's say 10 years down the road and you have autonomous vehicles, you're still going to have the majority of your labor force on a job site is going to be people. You still need people to build walls, plumb, build electrical. You still need all of that stuff, pour concrete, help all that, all those industries. But where you're going to have automation is things like the vehicle operators themselves. There's not very many on a job site. And that's where the high risk scenario is. And if you think about a vehicle operator, they're extremely talented, extremely skilled, but they work long hours in really tough conditions in Canada. And that promotes a lot of dangerous activity. Now, if you think about it, a crane operator is in a tower crane. They sit way up high with a little tiny heater and they can barely see anything and they work, long hours at a time. And it's natural, humans make mistakes. So yes, there will be some job displacement, but it's not going to be as significant as people project because you're still going to have the majority of your labor force are still going to be needed on the site, boots on the ground kind of theory.
Okay, awesome. That's a relieving answer, I guess. Okay, great. Next question here. This is quite a good one. How do you balance idealism and innovation, and what decides the limits of how unrealistic you can imagine in order to build an achievable product and not waste your time on something unattainable?
Ooh, that is a great one. That's definitely a coffee chat, but I'll try to keep it short. Start big, right? So really tackle a really big problem and then start to chunk it out into smaller ones. And you'll start to realize that where that realistic nature creeps into an idealistic concept is, building incremental steps, and realize and accept that you're not going to achieve everything at once. When you set out to do a project, you're not going to be able to achieve everything, but if you get close to achieving your goal, it's going to work. And cars are a great example of that. And I apologize for keeping using this analogy, but I'm a gearhead. Cars in the 90s and 2000s were terrible compared to now, right? So if you take a concept from the 90s and look at it, it was an achievable product for then. But if you were to take a concept from 2020 for a car, hybrid, 1,000 horsepower, able to be, partially self-driven, and you were to put that back in the 90s and 2000s, you'd be like, are you kidding me? That's never going to happen. But what I'm trying to show here is through lots of iteration over the years, you're able to take a very unrealistic achievement and make it tangible and doable. So again, it comes back down to chunk out every large project into smaller bite-sized pieces, and you'll be able to chew through it.
Okay, awesome. That's a great answer. Okay, let's go with this one next. How do you balance your time as CEO between operations, like reducing burn, and securing funding, whether through VCs or sales?
Yeah, this is a really tough one. And every founder, CEO, CTO, every owner of a company is going to have a different blend of what they need to do. And each personality has a different blend of what they like to do versus what they have to do. And that's a big differentiation. So things like running operations, reducing burn, and CEOs, you do have your hands in tech quite a bit. At least I do at my company. That's a large portion of your job. But what's important is think about it as like a roller coaster. I think is a really good analogy. So there are moments where you need to secure investment, you need to secure money, or else you can't achieve your goals, which means you can't build this tech that you want to build. So there's going to be moments where you climb the hill of securing fundraising. And you're going to be you're going to be focusing a lot of your time on fundraising at that time. And so what you do is you build in processes internally that help you run the business, not quite on autopilot, but thereabouts. And the goal is to not let disruptions happen internally while you're out fundraising, talking to investors, taking meetings, hammering the phones, whatever it might be. And then that also makes your operations more efficient, but then allows you to free up some time to go and secure some fundraising. And then usually what happens is you secure some fundraising, and you need to put that money into something, whether it's hiring new employees, whether it's developing new tech, whether it's scaling a marketing initiative, whatever it might be. So then you're actually going to then dive down away from the fundraising back into the operations and make sure that you then improve your operational efficiency again further than before your fundraising, right? So if you think about it, it's really an ebb and flow kind of idea where you're not trying to do everything at once. It's actually very compartmentalized, and you are bouncing back and forth between the two. The better you get and the more experienced you get, the more you can bounce back between two tasks and not lose cycles. When you're starting out, it's going to feel really challenging to handle everything at once. But if you look at how top executives and politicians, for that matter, handle their day, where they have a variety of things to do, they're very compartmentalized. They're very good at switching. From 10:30 to 10:45, it's this task. Boom. From this time to this task. From this time to this task. From this time to this task. And you just get really good at ticking through your day and achieving what you need to achieve. So I think it comes down to really strong organization and just realizing you need to get better at operational efficiency at each stage of the company that you go at.
Okay, awesome. Yeah, it's some really good advice for any entrepreneurs out there or anyone starting their own business. Next up, statistically, is it difficult to test for rare events? And with autonomous vehicles, how do you balance the safety of the public while testing for these rare events?
Yeah, it's a great question. Field testing is your best case scenario, not with real people, but you can mix simulation with some field testing for the rare events. So you try to account for rare events in your simulation. You're never going to get everything, but your data collection in testing should allow you to start to tackle those outliers and those anomalies. That being said, the reason that I decided to take construction sites versus something like airports is two reasons. One is it's an easier industry to adopt, but things move quite slowly on construction sites. So the actual rate and velocity of vehicles is low compared to, like, think about an airport with those baggage carriers ripping around the tarmac. Those are very high risk maneuvers with large outlying effects. Whereas on a construction site where you have slow moving objects, you can normally account for most of the things that happen on a job site, because when you talk in terms of autonomous vehicle world, cars on a roadway are doing 40 to 60K an hour, and at closing speeds are doing 80K an hour. Yeah, those scenarios are very hard to account for. But on a job site, things are moving in the 5, 10, 15 kilometers an hour speeds. Those are a lot easier to account for. And again, that's just how we took the path of least resistance for our company and our solution, because we don't have unlimited budget and resources to run all of these scenario-based situations. So not sure if that answers the question, but
I think it was quite a good answer. Yeah, it's definitely, it seems like a tough question, but I think that was a really solid answer. Okay, I think we're going to do one more
Sure.
before we move into a quick break. So is the lack of depth from 2D video feeds minimized by algorithms and triangulation of feeds?
The old secret sauce question. So I'm only going to go on the skim level. I'm not going to go deep because obviously I don't want to reveal our secret sauce. But you can do some very creative stuff with software. I think that's what I have to answer to this question. So the lack of depth from 2D video feeds is not a problem when you have an innovative solution. Let's put it that way. I think that's as comfortable and as deep as I'm willing to go on this one. But triangulation feeds are a great idea. You can also do sensor fusion. And what I mean by that is you can start to do things like integrate LiDAR and video feeds, or radar and video feeds, or GPS and video feeds. And then you can start to get a more holistic package of how to create 3D environments. But each sensor has its downfall, right? So video footage is really hard to extract three-dimensional information from. Our company's done an exceptional job at that. And that's what makes us unique, and our IP is differentiated. But that's really, really hard and difficult. So then some people might do things like GPS integration with that video feed. The problem is you stand around a concrete building and your video feed drops out, or sorry, your GPS feed drops out because you're beside a huge concrete structure, and you can't have triangulation to satellites. Same thing, LiDAR. LiDAR is only so good to a certain distance, and you're obstructed by line of sight. There's a whole bunch of things. So you can get creative with sensor packages as well. You don't just have to rely on video feed if video feed isn't working in that nature. But for our company, it's behind closed doors, unfortunately.
Yeah, I definitely like keeping it a bit of a secret there. Good answer though. Okay, awesome, David. Thank you so much for the presentation. That was terrific. I think people are going to be excited to get your slide deck later on. And yeah, that was a perfect segue into the pitch competition that we have later this afternoon, where you'll be joining us once again, which is awesome.
Yeah. Well, Max, thank you. Berkeley, thank you. And CUCAI, thank you for everything. It's a great event so far.
Okay, awesome. Glad you're enjoying.